Welcome on this snowy February day, and most of you are probably still in bed as I'm here making this video for you today on this snow day. Today we're going to start looking at the double angle identities from section 5 of chapter 5. And the nice thing about double angle identities is that they come directly from identities that we've already looked at. Consider, if we have the sine of theta plus theta. Well, we know from our angle addition formulas that that is sine of theta cosine theta plus sine of theta cosine theta. And rather obvious from that, we have the same thing in both spots, so that is just 2 sine theta cosine theta. And if we rewrite the left side just a little bit differently, we have the sine of 2 theta. So that's the first of our double angle identities. The sine of 2 theta is 2 sine of theta cosine theta. Next, we look at the same idea with the tangent of theta. So if we have the tangent of theta plus theta, according to our formula from the previous section, we have the tangent of theta plus the tangent of theta over 1 minus tangent theta tangent theta. And simplifying that, on the left side, we have the tangent of 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. And there's our identity for the double angle identity for tangent of theta. Our third formula for this type is for cosine of theta. So cosine of 2 theta, so we'll write it to begin with as cosine theta plus theta. And we know that cosines are cohesive, so we have the cosine theta cosine theta minus sine theta sine theta, or cosine of 2 theta is cosine squared theta minus sine squared theta. Well, the reason this is a little more involved is because of what we have at this point. Note that we can take this formula and substitute for the 1 minus sine squared theta. So we have cosine squared theta minus the quantity 1 minus cosine squared theta. If we make that substitution, we have 2 cosine squared theta minus 1. So it's a different form of that same identity, so you want to be familiar and watch for that. But of course, we also have that the cosine squared in the original from here could be replaced with a 1 minus sine squared theta, minus sine theta minus likewise, we could take that original formula of cosine squared theta. Try that again. Likewise, we could take that original formula of cosine squared theta minus sine squared theta and replace the cosine squared with 1 minus sine squared. So we'd have 1 minus sine squared theta minus sine squared theta, or 1 minus 2 sine squared theta. So all 3 of those are identities for cosine of 2 theta. And pretty easy to develop one